Minasyaitonirrajim. Bismillahirrahmanirrahim. Alhamdulillah Rabbil Alamin. Wassalatu wassalamu ala ashrafil anbiya'i wal mursalin wa ala alihi wa sahbihi ajma'in. Rabbi shrah li sadri wa yassir li amri wahlul 'uqdatam min lisani yafqahu qawli. My dear students, Assalamualaikum warahmatullahi ta'ala wabarakatuh. So inshallah, I'm going to share with you the third chapter for this subject. Now I'm going to look for the file. Okay, it's here. The third chapter is titled Descriptive Statistics. Okay, descriptive statistic. What do we mean by descriptive statistic? Previously, we learned about measurement. We learned about type of data, which consists of 4: nominal, ordinal, interval, and ratio. When you deal with SPSS, you will have different type of data. Only 3 type of data are allowed in SPSS, are provided in SPSS, which are scale, nominal, and ordinal. So for interval and ratio data will be under scale. Under scale, just put scale as type of data. Okay. What is descriptive statistics? This is the most basic form of statistics. Descriptive statistics usually you present in the beginning of your findings chapter. Before you go for correlation, t-test, ANOVA, you must present the descriptive statistic first. Yeah? It includes demographic background, such as gender, age, education background, or the nature of subjects you are studying. For example, you are looking at enforcement. So a part of their gender, their age, you may want to look. You may want to understand how many years they have been working in enforcement, how many years they have dealt with issues with drug addicts, for example. So those are under descriptive statistic. You don't measure correlation, you don't do t-test. Somehow these data can be related to other Likert scale data in the analysis. So descriptive statistic lays the foundation for all statistical knowledge. Foundation. You like it or not, you must have this descriptive analysis. La Buddha. Concerned with summarizing the distribution of single variable or measuring relationship between 2 or more variable. Remember, when I give you the task for descriptive, you have to present the gender, age, their experience in as environmental officer. So this is what we call by summarizing Yeah, and then you distribute them into frequencies and percentage. Descriptive statistics are used to describe or is used to describe the main features of a collection of data quantitatively. Features of collection data means the feature of your respondents, such as age, gender, working experience, can also relate to their working environment, food consumptions if you study on food. There are four descriptive statistics. There are four categories. The first one is frequency distribution, in which you have to look for frequency and percentage. And then measure of central tendency, or MCT. Measure of central tendency includes mean, median, and mode. I will explain to you what are they. Number 3, measure of dispersion. We look at range, standard deviation, and variance. And lastly, measure of association, which involves correlation, regression, ANOVA, Markova, yeah, even t-test. Measure of association, you are looking at relationship. T-test is also part of relationship, because we want to see is there any relationship between gender and communication skills, for example. Yeah? So it's called measure of association. Let's look at measure of central tendency. Okay. It provides a measure of the central value in a data set. The measures include mode, median, and mean. What do we mean by mode? This is the most frequent value in the data set. Yeah. Let's look at age. When you key in the age, there will have one set of numbers appears more than the others, appears higher than the others. 16, for example, 16 years old. When these numbers, this set of numbers appears higher or more frequent than the others, there is a meaning behind it. Why in your data collection there is more of your respondents at age of 16 years old? What do we mean by that? That is what we mean by values. Okay, and then median. Median is the middle value in a data set. I will show you what do we mean by middle value. This is not mean. Median is not mean. It's not average. Median is the position. The position of that set of numbers in the middle. If you look at 50 respondents, what is the middle numbers? You will have 2, because number 25 and 26 sharing as becoming the middle. So you have, then for this kind of case, you have to add 25 and 26 and then divide into 2, becoming the middle value. Okay, and then lastly is the average value of the data set, is the mean. This is what I mean by average purata. What is the mean value of the data set? You must look at the calculation. Yeah, You have to add all the numbers from of 50 respondents, and then you divide into 50. That is the main data. Okay. When you look for descriptive statistics, descriptive analysis, remember the 4 type of data. Yeah. This type of data, nominal, ordinal, interval, and ratio. Yeah. Okay. So nominal, for example, we look at gender, male and female. You can only extract, or you can only analyze mode for gender. You can't analyze mean for gender. It cannot be. You have female and then you have male. What is the median? You can't find any single value in the middle between male and female because they are nominal, they are not numbers. And then mean, can you average male and female become half man or half female? It cannot be. So you have to look for mode only. Mode means the frequencies, how many that male appears in your list. So if the if male appears higher than female, means you have more risk. Next is ordinal. Yeah. Ordinal. What is example of ordinal? Ordinal refer to, oh yes, certificate, educational, yeah. Educational background, we start with PM, certificate, diploma, what else, degree, master, and PhD. Okay, it's ordinal because there is ranking for the certificates. For this certificate, you can analyze the mode, how frequent each of these would appear, and then you can also look for median, the middle point. We will show you the calculation. The next one is interval. Refers to classes that has certain range between the numbers. That is interval. You can start from 1 to 5, 6 to 10, for example. Yeah. That is called interval. For interval data, you can get to find all three, namely mode, median, and mean. And lastly is ratio. Ratio is score. Ratio and score has always been used interchangeably. Some would use ratio, some would use score, but they're basically the same thing. Okay, so for ratio, you can also identify the whole three mode, median, and mean analysis. Remember, not every type of data can be analyzed for all descriptive of central tendency, major center of tendency. So let me bring you back to these 4 types of descriptive analysis. Just now we look at measure of central tendency, and the distribution is also being done. And then measure of central, measure of dispersion, and measure of association. Okay, don't worry, I will show you one by one. Now let's look at mean. Mean means average. It's simply the sum of the numbers divided by the number of numbers. The numbers divided by the number of numbers. What do we mean by that? You have 50 respondents. You have open-ended question for age. And then you have varieties in numbers, 18 years old, 20, 25. Now add them all, add up all of them. Once it's complete, divided into the number of numbers. How many respondents do we have? 50. So that is 15 number of numbers. The symbol kind of U, the symbol U is used for mean of population. The symbol M, the symbol U is used for mean of population. Population is the bigger group, okay? Sampling is the smaller group. So this U is used for mean of population, the big group. But the symbol M is used for the mean of sample. Okay? Sample, when you extract certain group of people from the larger group, we use M. Even in USIM, when you said you want to study on student from FEBU, okay, that is population. Why? Because you will have a smaller sample which you will study on year 2 students. That is sampling. When you have sampling, is smaller, so we use M. But for a larger group, you use the symbol U. Example, okay, 3, 2, 5, 3, 6, 9. But how many numbers are there? There are 1, 2, 3, 4, 5, 6. So M, the mean, equals to sum of data. You have to add them all. 3 plus 2 plus 5 plus 3 plus 6 and plus 9. After that, you need to divide into the numbers. What numbers? 1, 2, 3, 4, 5, 6. You need to divide into 6. So that is what we mean by average or mean of data. Okay. When you add up, there will be 26 for the score. Divided into 6 equals to 4.67. 4.67. That is the calculation of mean. Median. How do we get to know the midpoint, the middle point of the distribution? If you have 50 respondents, I believe you can sketch them on a piece of paper. But if you have 500 respondents, it's almost impossible for you to jot down every one of them, huh? Just to get the midpoint of distribution. You put them in a long one, and then you look for the middle. Okay. The median, the same number of score are above the median as below it. What do you mean by that? The median can also be thought as the 50th percentile, mean 50%, because it's the center. Okay. Before determining median value, arrange data in array. As I said, if 50 respondents, it's possible for you to sketch on the piece of paper, on a piece of A4 paper, but it's very unlikely, it's very impossible for you to do it if there are 500 respondents. Okay. Okay, and then calculate median location, ML, median, the symbol is ML, equals to n plus 1. N is the number of numbers. Let's say we have just now is 6. Okay, never mind. Okay, now we look at the example. Three, 2, 5, 3, 2, 3, 4, 5, 6, 7. There are 7. 7 numbers. I would say it's easier because you can easily find the middle. You have the first 3 and the last 3, and the number 3 is in the middle. That is the mid value. However, now you have to arrange them in array, means you start with the smallest number. Yeah, the smallest number. So the smallest number is 2 and must end with the highest number. In this case, we have 9 as the highest number. 2, 3, 3, 5, 6, 8, 9. Where the number end is, there is 6. 1, 2, 3, 4, 5, 6, 7. Okay. So 7 plus 1 is 8. Divide into 2 is 4. So you don't have 4 in this in the array, but you look at 4 means not 4 as the score, but the fourth. The fourth means is the number 4. So you count from the left, 1, 2, 3, 4. So 5 is the fourth of the array. So 5 is the median value. Okay. The most frequently occurring value is 5. But you must rearrange your data. We start with the smallest till the highest. Okay. Now, let's look at this data. We will come back to this as our task today, but keep this. You can keep this as one of our tasks today. Not assignment task. Just want to make sure it is a good exercise for you. Okay. I will come back to that. Now, we have the mode. Okay. This is the example. I will give you different data later. We will remind you to give this task. Okay. General guides of MCT. Use mode when variables are nominal. Remember the table that I showed you much earlier? You use mode when the variable are nominal. You want to present quick and easy measure for ordinal, interval, and ratio data variables. Use median when variables are ordinal. You want to report the central score and the score measured at interval and ratio levels have badly skewed distribution. And lastly, you use mean when variables are interval or ratio. You want to report the typical score and you anticipate additional statistical analysis. So this is general guides. The table is complete one, but this is general guide for you to better understand why do we need to use mode, why do we need to use median sometimes, and why do we need to use mean many times. Okay, next we go to measure of dispersion. Khalas for the measures central of the tendency. Now we look at measure of dispersion. Measure of dispersion measure how spread out a set of data is. Spread out. Spread out means what is the width? How big is your data? So it's expressed quantitatively the degree of variation. Remember when I asked you to collect 10 respondents from each members, because we want to create variation. We want to create diversities in your data. So when we use a measure of dispersion, we look at how spread means how big is your population is, how big your data is. Dispersion of values in population or in a sample. For example, the dispersion in the sample of 5 values. Okay, 5 values 98, 99, 100, 101, and 102 is smaller the dispersion in the sample of 18, 90, 100, 110, and 120. Although both samples have same central location, the median is 100, but the dispersion for the first one is smaller because it ends at 102. But the second group, the highest numbers highest number is 120, so the dispersion is bigger. That's what we mean by how spread out, how spread or how big your data is. The simplest measure of variability to calculate, and then the highest score minus the lowest score. Remember, this is to identify range for CI. Yeah? Highest value take away lowest value, and then divide. Okay, range at 6 to take away 2 is 4. This is for range. Yeah? We do it's different from when we do class K and CI, because in CI we divide into K, but here we look at just a simple measure to look at the range without having to decide on class. There are what I teach you, because it's part of the syllabus to teach you in any case that you want to identify classes, then you use the formula. But in this slide, this particular slide, we look at the range of data. Yeah. So you have to decide for example, in this case, 6 take away 2 is 4. You start with 3, 4, 5, 6. You stop at 6. And then you continue with 7. You can't do 7 because the highest numbers in this range is, in this group, is 6. You can't do 7. So your data is between 2 Hello? Okay. Let me share with you again the slide. Okay. Hope you can listen to me. The Okay, where did we stop just now? Variance. Okay, now let's look at variance. Variance describe how close the scores in the distribution are to the middle of the distribution. Is defined as average squared difference of the score from the mean. Is represented by the symbol S2. Yeah. Now the chapter becomes more difficult. Yeah, it becomes not to say difficult, but will be difficult to certain people. It's very technical when you have to remember the symbol. Previously we look at U, M. Okay, let me show you before we forget. Okay, it will come out in your quizzes, maybe in your final exam, maybe like. Okay, let me remind you. Okay, then use the symbol of M, the symbol of U. Yeah, what do you mean by U? What do you mean by M? Then we have ML, median location. Okay. This is these symbols are actually normals. You just need to be familiar with the symbols. This is measure of central tendency, MCT. We have covered the measure of dispersion, how's the spread of your data. You want to see the minimum and the maximum. Then we calculate the range, how they actually from one to another score, what range is possible, is acceptable. Then we have variance. We want to see how close the score in the distribution. So we use the symbol S2. S2, there is variance, but for standard deviation, yeah, the standard deviation is simply the square root of the variance. Kalau dalam bahasa Melayu is punca kuasa 2. Ya, punca kuasa 2. Simply the square root of the variance. Useful measure of variability, you want to look at the diversities when the distribution is normal or approximately normal. Normal range from the score cannot be more than 2, -2 or 2. So as long as they move between 0 to -2 or 0 to 2 is considered normal. So represented by the symbol S. Okay. So remember um, remember the variance S2 So this is the formula if we want to look for S2. Okay. Variance S2 equals to, what is this symbol? This is sum. Sum, okay? Sum X, what do you mean by X? The X is the whole score. And then take away population and then square. Yeah. Divide into N. N is the number of respondents. Take away 1. While standard deviation, you need to square root. The symbol represented by S symbol. Square root, and then we have sum, the same, and the S2, just square root the S2. I will not expect you to do this all manually because you have SPSS to work for you. So do not worry so much if I ask this such question in the exam. I will not do this. You have to bear in mind, if you have any question asking me, Madam, do you have any calculation? This is what we do mean by calculation, but not this one. It can be K, it can be CI, but not this one. But I have to share with you that when during my time, during my degree in UITM, we did all this manually. We did all this manually. I can't imagine how did I do it, but somehow I passed it with A. I know some of us may be very allergic with numbers. I'm also allergic with numbers because we basically come from the same background from religion school. Somehow it works on me. Maybe I'm not good at mathematics, but inshallah I love statistics. I'm good at statistics. Alhamdulillah. So this is formula 2, the standard deviation. The variance. Okay, the variance. And then standard deviation. This is example. So I'm trying to bring you to be with me for the calculation. Okay, what is the variance for this data set? You have the certain numbers. Let me count. 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 times 2 is 20. So you have 20 numbers. 20 numbers. What is the standard deviation for this data set? Now you have the data set. What is the standard deviation? First, you must calculate the mean value. How? So how do you define, how do you calculate mean? You have to add all together and then divide into 20. I think we better calculate together. So it proves right to you. Yeah. Let me do. You have calculator with you. 9. First is, it says calculate mean value. So how do we calculate mean value? We add all them up. Okay, 9 plus 7 plus 9 plus 7 plus 9 plus 6 plus 8 plus 6 plus 8 plus 6 plus 8 plus 6 plus 8 plus 6 plus 7 plus 6 plus 7 plus 5 plus 7 plus 5. Altogether is 140. 140, then we need to divide into 20. 140 divide 20 because there are 20 respondents. Okay, let me do this. One hundred 120 is 7. So the mean is 7. Subtract the mean from each score. Okay, this is the score. This is what I mean. Okay. The first is calculate the mean value, subtract the mean from each score. So each score, you have 999. Remember the numbers? You have to take away 7 from every score. And you have to take away 7 from each score. For example, here we have 9. Again, what is the instruction? Subtract the mean from each score. So the mean should be in the beginning. 7 take away 9 is -2. So that maintain the negative there. Someone please switch off the mic so we can share. Sorry, we can hear this slide clearly. Okay, 9 take so all for 9 is take -2. 7 take away 8 is -1. 7 take away 7 is 0. 7 take away 6 is is 1, and then 1 1. Okay. Actually, there is more underneath, but you cannot see it. So this is the main takeaway score. Then you have to square. You have to square them. Take away 2, square means 4. So mean takeaway score square. Then from S2, okay, S2, because we cannot see this slide. Wait. Okay, you can see from the bottom. Can you see the bottom? 140, and the square is 30. Yeah, the square is 30. Okay. So 30. So how do you define S2? 30 divide into 20. 20 is the number of your sampling. And take away 1. N is the number of your net sampling. Take away 1. Okay. Okay. So here we have 30. Then divide into 20, take away 1 is 19. 30 divide into 19 is 1.578. Okay, that is S2. S2. So how do you to get the value of S? So you need to square root. Square root 1.578 is 1.256. So that is basically how the formula works. Okay. So that is basically the slide that I'm going to show it to you about descriptive.